Thank you, Fabian, for the invitation. And what I'm going to present is something, it's yet another tool you can think which are there on the market, let's say, on the astronomical market for, let's say, time domain astrophysics, which is now blooming and on different angles and different areas of research. So I'm going to present you the tool we call BHTOM for black holes, of course, because it's a nice name and it's appealing. But generally, the idea here is that we try to make sure that even small telescopes can do big science. So hence my title of kind of subtitle of my presentation. I will start with showing some faces of people involved. This is actually this is run from the University of Warsaw Astronomical Observatory, where there is a bunch of postdocs and staff. But we are actually working on different topics. There is a OGLE project running there. There is Gaia project running there. We are involved in PESTO, Engrave, and projects you might have heard of. But kind of the common topic here is there is time domain astrophysics. These are microlensing events. These are supernovae tidal disruption events. This kind of topics. If we speak about people involved directly in developing the tool I'm going to tell you about, is actually essentially myself and Przemek Mikołajczyk, and there is Akont Lab company who is supporting us on the technical side of it. Of course, the basis of our software is coming from Las Cumbres Observatory, and we get a lot of support from them, and I would like to acknowledge it here. They made their software open sourced, and they provide a lot of support, so that's why that was the very basis of the tool we've built. And the funding we have, and we're part of a larger European infrastructure. So now it's called Opticon RadioNet Pilot Grant, which is running from 2021 until early 2025. This is 15 million euro grant from Horizon 2020. General idea of the grant, and it is, as you see, it has a lot of partners and collaborators. The general idea is that we provide access to infrastructures which are otherwise difficult to get to, especially for European, but not only European astronomers. So like VLTI telescopes, radio telescopes as well, and then there is support in form of excellence centers. There is trainings and workshops. Generally, the idea is to improve of observing services and data access, also harmonization of observing requests and proposal tools. And the last bit is actually what I'm contributing to this grant is virtual access to facilities via coordinated hubs in time domain. So we've been part of the Opticon project since 2013, and the idea comes from the fact that we realized that there are hundreds of small telescopes. Let's say I define small like from 0.3 to 2 meter, but this is very this can be extended both ways. And they're scattered around the world, and they're owned by universities, research institutes, outreach institutions, also private. These days, the telescopes are easy and cheap to buy, but they're hard to operate and use efficiently. I think you agree with that. So what we found, what we established early on in 2013, is that about 100 of small telescopes from around the globe, they have donated the observing time to our system for time domain observations. Primarily, it's concentrated about Gaia and potential black holes in lensing events, but essentially, broadly speaking, time domain. And we concentrated this work into a system we now call BHTOM, started in 2020, based on LCO TOM toolkit. And here you see an example of an object found by Gaia, an alert found by Gaia, and then the data contributed by small telescopes. So this is in principle the idea. The network, as I said, it was built around in dedication to Gaia alerts, but now it expanded to other things. and it consists of something nearly 100 telescopes scattered around the globe. Some of them are robotic, some of them are manual. And actually, we collaborate with both professionals and amateurs. Sometimes the telescopes owned by non-professional astronomers are better and provide better data than many of the professional instruments. So this is what we learned. But we collaborate with a very broad of instruments. You see, there's many instruments. There's a concentration of telescopes around Europe. This is kind of natural. These are the instruments. Some of them were built in over the last 100 years. These are, of course, not the best places. But the idea is that the more telescopes we have in the network, the better response possibilities we have. So that this is what we are trying to utilize here. This is an example of a real object we observed as kind of one of our first showcase example of one of the Gaia alerts. You see the black dots were the observations from Gaia, and then a star went bright for not known reason. And then we observed it for nearly 2 years with the suite of many telescopes, and we collected like 20,000 observations, multiple bands. You see different bands making different shifts in the magnitudes. And then we were able to trace this very sophisticated light curve, which turned out to be a binary system causing lensing of a star, a background star. And we were essentially able to completely figure out what this lensing system was. The binary, we essentially measured every single property of that binary without seeing the binary. So that's the power of microlensing. And of course, we're trying to utilize this tool for finding black holes. But of course, we find stars lensing as well. But we need a lot of observations like these to find these black holes among the lensed stars. So let me tell you a couple of stories. This is one of the telescopes which is involved in the network. This is Warsaw University Observatory telescope, 60 centimeter, founded in 1973. It's a horrible sight, as you can imagine. So imagine, maybe you can empathize. I will tell a couple of stories. You can empathize with any of them. Let's see. So the questions I'm asking, what can I use this telescope for? I only have 30 clear nights a year. That's not a lot, right? Maybe we can just close this and sell the forest to someone. I can go observing anytime because it's just next to Warsaw, but I don't know what to observe. I can process its data because I've been doing it for years, for decades, in an automated fashion. And my students also use the telescope for their training, but they also lack ideas what to observe. And I also need to justify the existence of this telescope with publications, of course, because otherwise it will be closed down. Another story you can imagine, there is a person coming, a user is coming with a request. There was a supernova in M101. I want this to be observed for how long it is necessary. So, and this person is approaching our telescope and then asks these questions. How can I access this telescope? Is there a way to apply for time? But the proposal page is all in Polish. It has a horrible weather pattern. Why should I bother actually with this telescope? Do I have to go there observing by myself? I don't probably want to do that. And also, how do I process the data if I manage to collect any? And yet another story you can imagine, and there is a user coming and saying, please observe this object, which is called Gaia 20 FNR, marked here with the star among all the other microlensing events discovered by Gaia. And so please observe this event for 1 year. It's very difficult to go to a time allocation committee, which normally allocate time, and ask for 1 year of observations of one target, right? So these people, they can come to us, and then they say, I need a long-term multi-wavelength time domain data for my target, right? Not only optical, I might need ultraviolet, infrared, even radio maybe in some cases. But I don't have access to any southern telescopes, right? For this, let's imagine, for this imaginary user. And no one is going to give me observing time for one target for 1 year, as I said. I don't have time to process thousands of images from different telescopes. And I'm going to write a paper about this target, right? So we collected all these stories, and that's why we came up with this idea for BHTOM within this Opticon RedNet pilot project. And generally, the reason for this it is a coordination of long-term monitoring of targets, of time domain targets. And the main thing we do and we provide to the community is processing of raw images. We do the PSF photometry from any type of instruments which are registered in our network. We then also do standardization and in an automated fashion. We use Gaia synthetic photometry for that. And then also we provide automated observation requests to whichever telescopes are suitable for that. Manual telescopes, not necessarily, but the robotic ones, they can respond to requests from our system. We recently updated our system. So it was redesigned to work faster, and it's now Dockerized, and it's using Kafka a lot. It has also access to vast number of archives. There is a lot of archival time domain data, which has been gathered by surveys like ZTF, of course, but there are also older surveys like Catalina, like Linear, Atlas, Assassin, Gaia itself as well. A lot of data which is now publicly available and is sitting there, and it actually is ready for science. Also, in one of our features is that we facilitate preparing publications. It's AI assisted, actually very fashionable these days, and it's customizable for users. You can have private filters, private targets. This is a map of targets selected, so it's an interactive map. You can look on the distribution of them, and this is the target list, which can be filtered in the way you want, and by coordinates, by magnitude, by the most recent magnitude, by the importance and the observing priority, also visibility, but also by the class. If you're interested in long period variables only, then you can filter on them, and then you can select the target you're interested. Of course, you can add targets. Any user can add any targets, any time domain targets can be added, and I'm talking about transients, supernovae TDs, whatever, microlensing events, but also variable stars or even quasars, which require long-term monitoring. They're also suitable, and they can be submitted in our system. And there are easier way you can grab the targets from Gaia Alerts, from TNS, from Antares broker, Simbad as well. And then, as I said, we query the archives. This is an example of a quasar flare, which we found very interesting. My student is working on that particular target, actually. But you see, there is a vast amount of data, like 20 odd years of observations, which seem to be very interesting and invaluable. And then we query all possible things as listed here. Some of the things are still in progress. It depends, as you might know, many of the surveys, they have horrible APIs, or they don't have even APIs. So you have to come up with a clever way how to grab the data from them. But this is what we've been working on. But this is done in automated fashion. Sometimes I myself was surprised seeing some additional data. I wasn't even aware it existed. And then the processing, this is probably the key element of our system, is that we have what we call CCD FOT. This is the engine, and it's a combination of Sextractor, DAO FOT, SCAMP, and all the kind of well-proven and robust tools. And it requires a manual setup per instrument, of course. We take a test image from you, and then we see how it processes. And then once it's set up, then the processing of your own images can be done automatically. And in most of the times, it's 99% successful. And it's fairly slow. It might take minutes per image, but we are Dockerizing it, so we might expand the network of these engines to speed it up. And also you can automatize fully. You can upload the images in a scripted way. So in principle, if your robot telescope is generating images which are standardized, calibrated, I mean flat fielded, debiased, dedarked, and then so you can send us your images, and we will process them in almost real time, and you can get the measurement on this light curve, for example. These are all the observations generated by the automated processing in multiple bands, of course, and then your data is being essentially available for further scientific use. Moreover, each data point, I don't have a slide showing this, but each data point carries the information of which telescope was used and who actually was the actual observer. So this preserves all the credits for people providing the observations, and this is also then used in the publications. And then the standardization I mentioned, this is another example of a transient we observed with our network. And then so we generate the instrumental data. You can also upload your own instrumental data if you have one. If you trust your own photometry better than ours, fine. But then you can use the standardization we provide, and then the standardization is automated, and it's matching Gaia synthetic photometry, probably the best all sky catalog of standards, which is there. Formerly, this used to be called Cambridge Photometric Calibration Server. There was a paper about this, but now it's built-in feature of BHTOM. There are some models already. You can start analyzing the data already in our system. Because I'm biased towards microlensing, so far we only have models for microlensing, but they're interactive. You can play with them, and essentially with one click of a button, you can get an idea of what this event is doing. You can get some first parameters, and actually it has shown for students, they can actually write the small research projects, just not coding anything, and essentially going through our system, and they can provide they can upload their own observations of a target, and then they can study the object in question with our tools provided. Then we also plan to expand this with other models like detection of the peak and slopes, periodicity, and also TDE models and so on. So this is modular and can be expanded with new models. There is, of course, an API. These days, you can't live without APIs. And because we want to talk with robots, ideally, then we provide the API for both uploading of the feeds and data, spectra as well, and also for accessing the target list and filters. So if your robot, for example, wants to find out what is the target I should observe tonight, then you can query our system. We will not provide you with the observing schedule. This you have to do it by yourself or with the tools available out there. But we can give you the targets of interest, which are now there in the system and which require any observations. And then, of course, data download and then standardization results. All of it is downloadable, and the documentation is there. And the documentation is growing. It's an open source code, of course, and everything can be accessed. And the documentation is there, slowly but steadily being added. As I said, publications is an important thing. So we try to facilitate it, and we generate automatically photometric statistics, which data and in which quantities it's been used, where the time range is, and also each observers are then listed here. Then we also use very simple API for ChatGPT to come up with a clever, catchy title for the work, and then some of these things might be useful when starting the publication. Right, and there has been already a couple of papers produced using our system over the last couple of years. And of course, there is a couple of papers related to microlensing, which Warsaw Group is typically leading, but not always. But we collaborate with other people, and there are a few Orioni type stars. There are some supernovae being observed, and any types of objects actually can be published using our system. There are 6 more papers actually in preparation or actually now being submitted on very different topics using the data we provided with the system. And as I mentioned many times, is that all observers are being acknowledged, are being offered co-authorship. So you see quite often the author lists are very long. But I think it's fair point that people contributing with their observations, they need to be credited for their work and their observations. We held workshops, and we actually started in 2010 in Cambridge already a long time ago. We focused on Gaia alerts in the first place for the first couple of years, and now we're actually now having workshops which are generally time domain meetings of the network of telescopes, but also our users. And Fabian himself, he attended one of the recent one in Malta we had. So we can access the data and the recordings of the workshops under this address here. And there is more information about the BHTOM itself, but also on all the applications people showed during the workshop. So it's all recorded and available there. And these are my contact details, so feel free to contact, and I will stop here. Thank you very much.